Welcome to the TOEFL Listening section. In this section, you will listen to an academic lecture and then answer questions about what you heard. You may take notes while you listen. You will have time to review your notes before answering the questions. Listen to part of a lecture in a university class. You will hear the lecture only once, so listen carefully. After the lecture, you will answer some questions about what you heard. Some questions ask about the main ideas and supporting details. Other questions ask you to make inferences or connections between ideas. Answer each question based on what is stated or implied in the lecture.
Good morning, everyone. Today we will focus exclusively on types of volcanic eruptions and how classification is driven by explosivity and lava composition. I will outline the common eruption styles, name their key characteristics, and give real examples so you can link theory and observation. A simple way to begin is with the distinction between effusive and explosive eruptions. Effusive eruptions produce lava flows that move rather than fragment and are typically associated with low viscosity basaltic magmas. Hawaiian and Icelandic styles are classic effusive examples. In Hawaiian eruptions, very fluid basalt forms long pahoeio and a flows, while in Icelandic eruptions, fissure eruptions can create extensive flood basalts. In contrast, explosive eruptions fragment magma into Pelean bombs and generate eruption columns and pyroclastic density currents. The primary controls are magma viscosity and volatile content. As silica content rises from basaltic through andesitic to rhyolitic, the magma becomes more viscous. This higher viscosity traps gas and increases the potential for violent fragmentation. Let us consider Strombolian eruptions. These are moderately explosive, driven by discrete gas slugs in basaltic to basaltic andesitic magma. They produce incandescent bombs and scoria and are exemplified by Stromboli in Italy. Vulcanian eruptions are more violent. They involve more viscous andesitic magma and generate short-lived explosive bursts that produce dense ash clouds and ballistic fragments. Mount St. Helens has shown Vulcanian phases prior to larger events. Plinian eruptions produce sustained high eruption columns and widespread ash fall. These are associated with high silica magmas like dacite and rhyolite. The AD 79 eruption of Vesuvius and the 1991 eruption of Mount Pinatubo are instructive. Plinian eruptions often reach high VEI values. Pelean eruptions are dominated by pyroclastic flows. They result from dome collapse or explosive interaction of viscous magma. Examples include the 1902 eruption of Mount Pelean, which generated devastating pyroclastic density currents. Phreatomagmatic eruptions occur when magma interacts with external water. This produces steam-driven fragmentation and can build tuff rings or maars. The Surtsey eruption off the coast of Iceland is a modern Surtseyan example where seawater produced explosive fragmentation. There are also phreatic eruptions, which are steam explosions that fragment existing rock rather than fresh magma. They can occur in hydrothermal areas without new magma reaching the surface. A useful quantitative tool is the Volcanic Explosivity Index, or VEI. This scale rates eruptions by plume height and erupted volume and helps compare events from small Strombolian explosions to massive Plinian eruptions. It is important to link composition to hazard. For example, the basaltic effusive eruptions pose threats from lava flows and localized fires, while rhyolitic explosive eruptions can produce widespread ashfall, global climate effects, and lethal pyroclastic flows. Consider Mount St. Helens in 1980. The eruption combined an initial explosive phase with a lateral blast and later dome building. This sequence illustrates how an eruption can transition between styles as magma composition and gas content change. When I say that rhyolitic magmas produce the most explosive eruptions, I mean they combine high silica with high gas content, making fragmentation likely. In applied volcanology, recognizing eruption type informs emergency planning. For example, knowing a volcano is prone to phragmomagmatic activity helps planners anticipate localized tsunamis or coastal hazards in addition to ash and ballistic fragments. To summarize, classify eruptions by their explosivity and by lava composition. Effusive basaltic styles are distinct from explosive andesitic and rhyolitic styles, and intermediate forms like Vulcanian and Strombolian occupy a middle ground. In our next session, we will analyze eruption deposits to practice identifying eruption styles from field evidence.
Listen again to part of the lecture, then answer the question.
When I say that rhyolitic magmas produce the most explosive eruptions, I mean they combine high silica with high gas content, making fragmentation likely.
This concludes the listening section. For more TOEFL practice tests and study materials, Visit spinta.org.